Basic calculus. I know this will be tiring to watch, and I also know that you want now to stop this video and just watch entertaining one. But do not close or stop this video because you will learn from this. So, let's get started. First thing to know is the definition of antiderivative. Antiderivative is a key component of indefinite integrals and is the opposite or reverse of derivatives, wherein f of x is an antiderivative of f of x if f prime of x is equals to f of x. We can also say that if f prime of x is equals to f of x, then the general antiderivative of f of x is f of x plus any arbitrary constant, wherein we call it letter c. It means that the function can have many antiderivatives, but they all take the form f of x plus c.
Now, let's know the symbols used. The first symbol is called the integral sign, denoting the operation of the antidifferentiation. The next is the function f. It is called the integrand. If f is an antiderivative of f, we write the integral f of x times dx is equals to f of x plus c. The integral sign and the dx go hand in hand, and the dx helps us to identify the variable of integration. Then the expression f of x plus c is called the general antiderivative of f. Meanwhile, each antiderivative of f is called a particular antiderivative of f. And lastly is the use of the power rule, which is x to the n plus 1 all over n plus 1 plus c.
Since you have already learned the meaning of antiderivative, let us now show you some real-life problems that involves antidifferentiation.
Using the formula integral of f of x times dx is equal to f of x plus c, we can have our first real-life problem as this. Suppose Jerilyn is answering a calculus problem involving trigonometry. What will be her answer if she have the problem of integral of 5 sine x plus secant squared x times dx?
First, to do is separate 5 sine x and secant squared x into 2. It will be integral function of 5 sine x plus integral function of secant squared x times dx. Second, separate 5 from the 2. 5 integral function of sine x dx plus integral function of secant squared x dx. Third, find the antiderivative. For sine x, the antiderivative is negative cosine x, while for secant squared x is tan x. And don't forget to add c since we don't know what number is there. Since we still have number 5, we just have to fix the placing of numbers. Our answer is negative 5 cosine x and tan x plus c.
Alright, so we have just finished our first problem. Now on to the second one. We have Badette is having difficulty in solving an antiderivative. Luckily, her classmate Califord knows how to solve the problem. If they are looking for the original function, the value of c and d from the given f of x is equals to 27x squared plus 4x plus 12, where f of 1 is equals to 6 and f prime of 1 is equals to negative 4, find f of x.
First, we will use the formula of x raised to n plus 1 over n plus 1 plus c. For 27x squared, it will be 27x cubed over 3. For 4x squared over 2, for 12, we will put the variable x beside it. 12x, then plus c. Then lowest term if possible. F of x will be equals to 9x plus raised to 3 plus 2x squared plus 12x plus c. Next, f of 1 will be equals to 9 times 1 raised to 3 plus 2 times 1 raised to 2 plus 12 times 1 plus c, since we have to place the value of x, which is 1, to the given function. Negative 4 will be equals to 9 plus 2 plus 12 plus c, since it is said that f of 1 is equals to negative 4. Transpose the values. Negative c is equals to 4 plus 9 plus 2 plus 12. Negative c will be equals to 27. Multiply both sides to negative 1 to remove the negative sign on the variable c. We will have negative 27.
Now that we have the first answer to the problem, which is the value of c, negative 27, we will use this for our step 2 to find the original function including the value of d. Now that we have f prime of x is equal to 9x cubed plus 2x squared plus 12x minus 27, we now need again to use the power rule of x raised to n plus 1 over n plus 1 plus c. We'll have 9x to the 4th power over 4 plus 2x cubed over 3 plus 12x squared over 2 minus 27x plus d. Then, we have now f of 1 is equal to 9x to the 4th power over 4 plus 2x cubed over 3 plus 12x squared over 2 minus 27x plus d. Fourth, replace x variables with the value of x, which is 1. F of 1 is equal to 9 times 1 raised to 4 over 4 plus 2 times 1 raised to 3 over 3 plus 12 times 1 raised to 2 over 2 minus 27 times 1 plus d. We will have 9 over 4 plus 2 over 3 plus 6 minus 27 plus d. 6 is equal to 9 over 4 plus 2 over 3 plus 6 minus 27 plus d, since the f of 1 is equal to 6. Transpose. Negative d is equal to negative 6 plus 9 over 4 plus 2 over 3 plus 6 minus 27. Negative d is equal to negative 289 over 12. Multiply both sides to negative 1 to remove the negative sign on the d variable. Now we have found the value of d, which is d is equal to 289 over 12. Now we have found the original function of the derivative, which is 9x to the 4th power over 4 plus 2x cubed over 3 plus 6x squared minus 27x plus 289 over 12.
Since we have now completed the first two problems, this will be the last one. Bell and J are partners for the activity in their calculus subject. If they're going to make double antiderivatives, wherein the values of x are 4 and 2, while the values of y are 4 and 0, of the integral of the function x and y plus x squared and y cubed by dy and dx, what will be the answer?
The first thing to do is to represent the problem. Letter A, it will be integral 4 and 2 and integral 4 and 0 of the function xy plus x squared y cubed dy dx. Letter B, the next thing to solve is the y value, so we'll have integral 4 and 2 parenthesis integral 4 and 0 of the function xy plus x squared y cubed dy parenthesis dx. Letter C, do the power rule on the inside function. We will have integral 4 and 2 parenthesis integral 4 and 0 of the function xy squared over 2 plus x squared y to the 4th over 4. Y is equals to 4 and y is equals to 0 dx. Letter D. Next to do is to replace the y values to the variable y. We will no longer include 0 since it has no value. We will have integral 4 and 2 parenthesis is the function x sub 4 squared over 2 plus x squared sub 4 to the 4th power over 4 parenthesis dx. Letter E, we will have integral 4 and 2 parenthesis of the function 16x over 2 plus 256x squared over 4 parenthesis dx. Letter F, simplifying, it will be integral 4 and 2 parenthesis 8x plus 64x squared parenthesis dx.
For the second part of the solution, we need to use the x values, which are 4 and 2. Since we now have the equation 8x plus 64x squared dx from the first part, the next step to do is use the power rule. Once we use that, we will then get 8x squared over 2 plus 64x cubed over 3, where 4 and 2 are our x values. We will then simplify the equation to 4x squared plus 64x cubed over 3. Once we've done that, we can then replace the x variables with 4 and 2. So we will then get 4 multiplied by 4 raised to 2 plus 64 multiplied by 4 raised to 3 over 3 minus 4 multiplied by 2 raised to 2 plus 64 multiplied by 2 raised to 3 over 3. So once we've multiplied that, we will get 64 plus 4096 over 3 minus 16 plus 512 over 3, and we can further simplify that to 4,288 over 3 minus 560 over 3. After that, we will subtract it and get 3,728 over 3. Now we have found the answer for Bell and Jay's calculus activity, which is 3,728 over 3.
That's a wrap, guys. We had a fruitful discussion. So, we hope that you learned from this video, and we are glad that you didn't stop or close this video since we know that basic calculus is not an easy subject. Don't forget to hit the like button, subscribe, and click the notification bell for more videos. Thank you for listening. Bye!